All right, guys, today's lesson is just going to be on solving logarithmic equations. So there are two different types of equations that we're going to solve. As you can see, the first one, you only have the log on one side of the equation. The second type of problem, you have the log on both sides of the equation. So I'm going to show you how you would solve each of these. Now, the first thing that I want you to remember is if you have the log base b of x equal to y, remember that that is the same as b, the base raised to the exponent, and that would be equal to the value. Now, this is what we call the definition of a logarithm, because that was the original definition that I had given you. Now, we hadn't really talked about this that much up until this point, but in that original definition that I gave you, we always had to have a value of b, so our base had to be greater than 0, meaning it cannot be negative, and the base couldn't equal 1. And for the most part, I wouldn't give you anything like that anyway. But what you really have to remember for this is that the value of x also has to be positive. So x has to be greater than 0. Because remember, if you take a number, positive number, and you raise it to any power, it has to be positive. It might be really small. Okay, if you raise it to negative 100, you're going to have a really small number, but it's never going to be a negative number. So this is something that you're going to have to remember, and you're going to have to check your answers and make sure that the value of x, or in this case, this value here, not necessarily just x, but that value has to be positive. So I'll show you what I mean in a minute. So like I said, there are two types of equations that you're going to solve. The first one you see, you only have the log on one side of your equation. That is really important. So when you only have the log on one side of an equation, you will use the definition of a logarithm to write this in exponential form. Okay? Log on one side, always change to exponential. Okay, so that's what you had done on the first day of homework, was changing them back and forth. So if I change this equation, I have log base 9, so 9 is your base. The exponent is the 3/2, and that's equal to the value of x. Now, we have to remember our rational exponent rules. If I have an exponent of 3/2, that means the index is 2, so it's a square root. So I have the square root of 9, and I'm raising that to the third power. So the square root of 9 is 3. 3 cubed is 27. You double check. 27 is this value. It's positive, so you're good to go. Okay. Now, do the same thing for number 2. I have the log on one side, so I rewrite this in exponential form. So the base is x. The exponent is 2. And that's equal to 49. Now, you might be thinking that if you take the square root of both sides, you'll end up with plus or minus 7 as your value of x. However, we can only use the positive 7 because our base has to be greater than 0. So x cannot equal the negative 7. So your only answer there is the positive 7. Okay, so log on one side, rewrite it in exponential form. All right, the next type of problem is when you have the log on both sides of an equation. Now, one thing that you're going to notice is that they always have to have the same base. Okay. If they don't have the same base, we cannot use this method. We wouldn't be able to solve it. So you'll notice in this first problem, they both have a base of 2. In the second one, they both have a base of 3. Okay, so when you have the log on both sides of an equation, all you have to do is take the two values and set them equal to each other. Now I'm going to have to solve this. I have a quadratic, so I move everything to one side and I factor. And then I solve it. Again, you can pause this as you work through this. I guess you should have paused it before I did the problem. So now you check your answers. So when I plug 4 in, 4 squared is 16 minus 4 is 12. It's positive, it's fine. When I plug 4 in over here, 3 times 4 is 12, positive, fine. When I take the negative 1 and I plug it in to either of them, it doesn't matter which one you plug it into, 3 times negative 1 is a negative 3. But this entire value here has to be positive, so that does not work. So my only answer is x equals 4. Okay, then we try it again. Number 4, again. Pause this, try the problem, and then you could just check it with mine. So I set the two values equal to each other. I'm going to factor. I get x equals negative 5 and positive 3. Now, I specifically chose this problem because we have to, again, check all of our answers. Don't just look at the sign of your answer. You actually have to plug it in and see what the value becomes. When you plug negative 5 in, negative 5, when I square it, becomes positive 25 minus 15 is still a positive 10. When you plug negative 5 in over here, negative 2 times negative 5 is a positive 10. So x equals negative 5 is a solution that works. When I plug a 3 in, negative 2 times 3 gives me a negative value. So the 3 does not work. So the only thing that works is x equals negative 5. Okay? The homework that goes along with this is going to be on the next page, the equations and inequalities homework. You are just doing numbers 1 through 10 for today.